This video is on phase diagrams. So phase diagrams is a diagram that's going to show the three different phases that all things can exist in. The solid phase, the liquid phase, and the gas phase. On a phase diagram, looks like this, there are two important points that we want to know. The first of which is the triple point. The triple point is where pressure and temperature give us a point at which all three states of matter exist simultaneously. So they coexist. So it's a solid, a liquid, and a gas. The other is the critical point, and this is the point at which the pressure and volume, the distinction between liquid and gas, can no longer be made. So we have our phase diagram, and what you want to do is draw this shape on your phase diagram. There are three different quadrants. Here we have solids, then liquids, and gases. The point where pressure and temperature, well, we have pressure on our y-axis, temperature on our x-axis. Pressure is in ATM or atmospheres. Temperature is in degrees Celsius. Where all three coexist would be the point where they all come together, here, where they have a pressure and temperature, where all three coexist. This is their triple point, TP for short. Then, where liquid and gas can no longer be made, well, that's going to be on this line here, between liquid and gas. At the very end of that is your critical point. So they can no longer be distinguished. Along each of these lines, an equilibrium exists. In other words, along this line here between solid and liquid, both the solid state and the liquid state are coexisting. So you can have solid and liquid occurring at the same time, as long as it's at the same pressure and temperature given on these lines. Now, water has a specific phase diagram. It has a negative sloped line between the solid and liquid. So this line here, as shown on this diagram, has a negative slope between solid and liquid. So we know that this is water. All others are going to have a positive slope. We also have the normal melting and freezing points and the normal boiling and condensing points. Now, normal refers to being at 1 atmosphere, which is the normal atmospheric pressure. At sea level, it's 1 atmosphere. So we can read on our diagram, at 1 atmosphere, we draw our line across. And where it intersects, and we go down, that's going to be our normal melting point and boiling point. Melting between solid and liquid, so it should be 0 degrees Celsius for water. And boiling between liquid and gas, which will be 100 degrees Celsius for water. Now, moving between solid, liquid, and gas, we have phase changes. Now, these are physical properties and physical changes of different substances. Phase changes can either be endothermic, absorbing heat and the temperature increases, or they can be exothermic, where they're releasing heat and the temperature decreases. We have 3 of each. The 3 endothermic phase changes will be from solid to liquid, because my liquid molecules are moving around much more my solid molecules. Solid molecules are very stationary. Boiling from liquid to gas, and sublimation from solid to gas. So this would be an example of dry ice, and that creates the fog. Exothermic examples are freezing liquid to solid, condensing gas to liquid, and deposition. Deposition is how snow is made. The vapor, the gas water in the clouds gets cold, and as it comes down, it becomes a solid.